Hello and welcome to this tutorial on setting drawing scales in Model Space. This tutorial will focus on calculating and setting up the plot scaling for drawings with borders inserted into Model Space. Drawings created with Paperspace viewports and drawings created as not to scale will not be covered in this tutorial, but will be the subject of separate lessons. To get started, it is important that we understand a little bit about scaled technical drawings. With few exceptions, a drawing can be thought of as an instruction manual on how to create a design of something such as an automotive part or some other object. Depending on the object of your drawing, there may be a number of different processes used to create the object, such as drilling, cutting, lathe operations, or any other industrial process. The drawing will not only show the dimensions of the item being drawn, but will also include different line types and any notes relating to special materials, processes, or any other necessary information needed to create the item. It is important to set up the scaling parameters so that when the drawings are plotted or printed, all parts of the drawing are easily understandable, meaning that they are formatted to the correct size according to officially accepted standards for ease of readability and consistency from drawing to drawing. In AutoCAD, the scaling of a drawing will affect the size of the text and other annotation objects such as lines and arrows. When we refer to the scaling of a drawing, we are referring to the plot scale, or what the objects look like when the drawing is plotted or printed out. It will be your job to decide or figure out what scale you will be using when creating your drawing. The size of the object and the number and type of views that you will need to best present your drawing will guide your decision, as well as other factors related to your drafting discipline. Before we show the process of calculating a scale factor for a drawing, let's take a look at some tables with some commonly used standard plot scales. We will also look at the dimensions of an A-size drawing and border. The first table is the proportional plot scale table. Looking from left to right, the first column is the plot scale which you will find in a drawing title block. The next number is the scale factor. It is a multiplier that will be used to set up the parameters in a drawing, and it is calculated using the plot scale values. This is the number that we will learn to calculate in the event that you do not have a scale chart available. The next number is the line type scale, which is basically the scale factor divided by 2. The line type scale controls the appearance of dashes, dots, and gaps in lines types such as hidden lines, center lines, phantom lines, and any other lines that are not solid continuous lines. The next two columns show the regular text height and the title's text height for drawings at that plot scale factor. The last column is the dimensions of your border in model space after you have scaled up the border using the scale factor. Not shown here and in the next two examples are columns showing scaled border sizes for B, C, and D size drawings. Since we are focusing on the process of scaling borders, we are excluding them for this lesson, but it should be understood that the scaling process will be the same for those sizes as well. The next scale table is the architect scale, and it is set up just like the proportional scale with the same type of columns. Notice the plot scale numbers in the first column and the scale factor numbers in the second column, and how they differ from the proportional scale. These plot scale factors result in higher scale factor numbers. These are used for drawings that are larger in size than the scale factors in the previous chart. The last scale table is the engineer scale, and as you can see, it shows scale factor numbers higher than the previous two scales, which means it is used for drawings covering a much larger area than the previous plot scale tables. In this frame, we can see an A-size drawing on an A-size sheet. Notice the size of the sheet on the left side of the drawing. It is the size of a standard sheet of paper, just like the paper that is commonly found in any printer. The A border on the drawing is 7.5 by 10. This is the size that you will create your border in class as a separate drawing, and the size that it will be when you insert your border into your new drawings. You will then scale the inserted border up to the size needed for your drawing using the calculated scale factor only after you have inserted your border. To help us understand plot scales, let's look at 3/8 inch equal 1 foot as our example. As you can see, the number on the left on paper represents 1 foot in the real world measurements, or in other words, for every 3/8 of an inch that you draw or is on the paper, the real world distance will be 1 foot. The next illustration provides another way of looking at scaling that may better help the student understand the concept. Imagine that you have an ordinary ruler in your hand and you lay it flat on your drawing and measure each one of the 4 line segments on the paper. The lengths of the line segments are shown above the arrows, and the measurements in model space at which you draw those segments is shown below the line segments. Although the concept of scaling may be difficult to understand at first, you will gain a better understanding of the concept with repeated use. One important thing to remember is that you will always draw your object in real-world measurements in model space with very few exceptions. Now let's use our example plot scale of 3/8 inch equal 1 foot to calculate a scale factor for a drawing. In step 1, we must first convert our units on the right side of the equal sign to the same type of units as on the left side. In this case, we would convert 1 foot 0 inches to just inches, which would give us 12 inches. In step 2, we would divide the number on the right of the equal sign by the number on the left of the equal sign, which would give us 12 inches divided by 3/8 inches. The resulting division would give us a scale factor of 32. This is the number that you will use for setting up the scaling for your drawing. In the next few slides, we will examine using the scale factor to accomplish this. This figure shows the Fit tab of the Dimension Style Manager. Your border should already contain a dimension template with variables such as arrowhead size, text size, and several other variable sizes set at a drawing scale of 1 inch equal 1 inch. In the Fit tab, you will use the calculated scale factor to change the Use Overall Scale Of to 32. Changing this number will control the scaling of all of the previously set dimension variables in your dimension style. This eliminates the need to individually adjust a number of dimension variables when creating scaled dimensions. They are all changed simultaneously by changing one variable. The next two drawings are provided as a comparison of scale factors. In the first drawing of a floor frame made of 2x4s, notice the size of the entire frame. Remember that the frame is drawn in model space at the actual size according to the dimensions shown. Looking at the scale shown in the title block, this tells us that every 1/4 of an inch on paper is equal to 1 foot in real-world measurements. Let's use our scale factor calculation process to find the scale factor for this drawing. First, we convert the units on the right to obtain equivalent units. Then we divide the number on the right by the number on the left to obtain a scale factor of 48. So this would be the scale factor for this drawing. The next drawing is a mechanical part drawing called a mounting plate. Notice that the size of this object is much smaller than the previous floor frame drawing, and thus it is created using a drawing scale of 1 inch equals 2 inches. So for every inch measured on the paper, the equivalent real-world measurement is 2 inches. For this scale factor calculation, the units are already the same, so the unit conversion is not necessary, making our calculation much simpler. Using the division, we arrive at a scale factor of 2 for this drawing. In wrapping up this tutorial, there are some important things to consider as shown in the bulleted list here. They are: when choosing a scale factor, the border must be large enough to accommodate all views and dimensions without crowding. Remember that your drawing should look professional and readable. Borders must be scaled to a scale factor from a standard scale chart. Don't forget that you must change the LT scale variable according to your calculation, and the text size must be entered at the correct scale value as well. Understand the difference between drawing scales and scale factors. The scale factor is a multiplier resulting from the scale factor calculation. We hope this tutorial gave you a basic understanding of drawing scales and scale factors. For a deeper understanding, consult your textbook or any of the available library resources. Thank you for watching, and goodbye.